Images are one of the most fundamental data visualization types, especially so if you're working with computer vision models. You might want to look at the input images to your model, for example, or you might want to visualize a kernel or activation from a convolutional layer downstream in your model, or maybe even you want to visualize the bounding box predictions that are made by an object detection model. So there's a whole host of reasons why you'd want to visualize images. And with MXBoard, it makes it very easy to save ND arrays to image format for visualization in TensorBoard. So we'll see an example of that now. Now the image that we're going to be using for this demonstration is from SciPy. And we get the image by calling misc.face, and that's just going to give us a random face image to work with. The dimensions of this image are slightly different to what we'd want with MXNet. So first thing, we're going to convert from the SciPy format to ND array. We can create the ND array from this by calling MXND.array. That's going to convert everything to an ND array. And now we can go ahead and convert to the correct format expected by MXNet. We're going to move from height, width, channel, which is what our image is currently, to channel, height, width. We can use the transpose to do that rearranging of the dimensions, specifying the order in which we want the new dimensions to be. And because the values of missed face were integers between 0 and 255, and we want the values between 0 and 1, we have to do the division by 255 so they're in the correct range, the pixel values are in the correct ranges. Now it's pretty typical when you're working with computer vision models to have batches of images. You're not just working on one image at a time typically. So we're going to recreate that scenario by creating our own batch. And our batch is going to be of 15 images in this example. So we take our face image, and we're going to create a batch dimension, and then we're going to repeat it 15 times, and then combine everything together with the concatenate function. So now face batch represents a batch of 15 images. Now that we've got this ND array, really simple to add the image to the summary writer. So we can create our summary writer. We specify the same log directory as usual. Now we have access to SW alias, and we call the add image method on our summary writer. We tag things as we usually do, just so we can get a label in TensorBoard so we know exactly what we're looking at. And we pass the data via the image argument. So here we're setting that to face batch, which was our batch of faces, which was in ND array format. Now after we run this, it's going to save everything to disk, all that image data, and we should be able to see that now in TensorBoard. So let's move over there now. Great. So in TensorBoard, we have a new tab. It's called the Images tab because it's automatically detected that there's image data in that log directory folder. And we see our label that we'd given. It was our tag. We called it faces. And now this is the rendering of that data. So MXBoard automatically sorts the data and creates the grid because we provided a batch of images. You don't see every individual image, but you see them all on one grid. And that's very useful for visualizing lots of images at once. We didn't provide a step, so by default, the global step will be 0. If we were to add and visualize images through our training, we'd have different steps and we can scroll between the steps, and we'll see an example of that in a minute. We've got a few other options for visualizing. This has been reduced in size so it fits on screen, but we can view the actual image size by clicking the checkbox here. That's going to show a full size, a nice friendly face. And you can also do that by double clicking on the image too. We've got some adjustments, so we can change the brightness and the contrast to whatever suits. And as usual, we can filter to different runs and filter on different tags. So now let's look at a real-world example of using the image feature of MXBoard. So this is a model that is trying to predict the bounding box of lines of handwritten text. And we're looking at how the model is performing over time. So in our first instance here, we have bounding boxes of the labels, so the correct bounding boxes, and in the dashed lines, we've got the predicted values. So at step 40 in this case, the predictions are pretty good, but we've still got some errors along the sides. So now if we watch the video progress through the steps, we can see the model starts to converge and get better and better, more accurate predictions. So this is a really good tool for visualizing how well your model is performing and potentially spotting areas where you could improve the model. Maybe you notice that there's an offset or a shift in certain areas, or the model's struggling to pick up certain objects. So it's a really good tool for diagnosing problems as well.